So sine, cosine look practically the same, but one is just shifted over a little bit, right? So with sine and cosine, yesterday whenever we were looking at them, let me pull it back up here on Desmos. If I've got f of x equals sine x versus, let's call it g of x equals cosine x, they look practically the same, but I can tell sine has a y-intercept at 0, 0, and cosine has a y-intercept at 0, 1. Right? That comes from our unit circle. Sine of 0 is 0, and cosine of 0 is 1. Now, when we start shifting things, this may not be 0, 0, and 0, 1. But sine has a y-intercept at the midline if it has not been shifted left or right. And cosine has a y-intercept at a maximum point there. So, for these first two questions that you have here, like the midline of this graph right here would be right here. Now, sine typically has a y-intercept at the midline, which is what is happening here. But sine also, you have that y-intercept, and then we usually have the positive part of the graph, right? So, like if we're starting at 0, our sine values are 0, 1/2, root 2 over 2, root 3 over 2, positive 1, right? We have positive numbers there. But does that happen on this graph right here? It does not, because normally sine would look, like this. It would be, we'd have positive part first, then the negative. So there are two ways to deal with that whenever that happens. You can either use a phase shift. You can shift it to the left or to the right, or you can reflect it over the x-axis. In this particular case, they want you to use a reflection because if you look at your formula right here, do they have a plus c in the formula? They do not. So whenever you look at this, your amplitude is the distance from the midline to the maximum, which is just 2 in this case. So you're going to have h of theta equals 2. I'm going to leave a little space right there. Sine of, I'm going to worry about the inside here in a minute. And then I've got plus the midline. The midline for this one is 1, right? So that this is going to look more like that red graph that I have there. To flip this, you're just going to put a negative right here, and then it'll line up. I don't have the period right yet, but that'll take care of amplitude and midline and have the graph line up there. So that B value is a little bit harder to find, right? So to find the period, we do 2 pi divided by whatever that B value is, right? That was our formula. Hopefully you saw that yesterday when you looked at that stuff on the notes. So you would have 2 pi over B. Gives you the period. What is the period of this graph? How long does it take for this graph to repeat itself? Pi. So pi is our period here, right? So pi is what we're going to get when we do 2 pi divided by B. What number do we need for our B? Right there. 2, right? Because 2 divided by 2 would be 1, and we just get 1 pi. So we've got 2 theta for that one. Okay, questions on that part? For number 2, they tell us this is a cosine function. Cosine function actually makes this the easiest to deal with here because if we want to draw in our midline is right here on this graph, right? Cosine usually has a y-intercept at a maximum point, right? And this graph has a y-intercept at a maximum point. So do I need to flip this or shift it left or right? I do not. I just have to change the amplitude and the midline and the period of the graph. So cosine would be the easiest one to do, and they've asked you to do cosine here. So f of theta equals, A is our amplitude, right? So Braden, what's the amplitude on that one? 3. So we got 3 cosine of, I'm going to worry about the insides last. They're the ones that are a little bit harder. And then I add my midline over here on the end. Asher, what's my midline on this one? 1 there. And then that B value, we got to think of the period of this graph. Period is how long this takes to repeat. So if I see how long it takes to repeat, that would be from 0 over to 4. So the period here equals 4. The biggest mistake students make is they just plug 4 in right here. They say 4 theta. And that is wrong. The B value is the only one where we're not just plugging in the numbers, right? So we have to think, to find period, I do 2 pi divided by B, and that needs to equal 4 in this case. The other one was pretty easy to just think like, oh, well, I just need to plug in, 2. 2 divided by 2 will give me 1. I'll get the answer. This one's a little harder to do that, right? So what we can do is we can solve this little equation for B. To do that, we would multiply both sides by B. So 2 pi would equal 4B. And then we would divide by 4. And that will reduce to pi over 2 for our B. So we get pi over 2 times theta right here. Yes?
Could you just plug in the period for me and then simplify?
What do you mean by that?
Just start with 2 pi over 2.
Yes, because so our little formula here, 2 pi over B, that's how we find our period, equals whatever the period is, right? So I'm going to say equals the period, right? So if we did this without numbers here, if we multiplied both sides by B, we would have 2 pi equals the period times B, and then we would have to divide by whatever the period is, right? We're doing basically the same thing I did over here, but with that number. So B does also equal 2 pi over the period of the function. So you can do it that way. You have to have those two things memorized. A lot of times I stick with one formula and work from it because kids get those two mixed up, so be careful. If you do that, sometimes they'll mix them up and do the opposite. To find the B, they'll do what they should do for the period. So just make sure, as long as you've got it straight, this will always work, yes. Because it's just sort of like a rearrangement of that same formula. Yeah. Okay. Questions? Okay, let's go down to number 5, because 5 is a little bit trickier because they don't tell you which one to use on 5. And in fact, there are infinite correct answers on number 5. All right. I think the answer key is probably just going to give the easiest, most common one to do, but they just ask you to write the graph of a sinusoidal function here. They do not tell you what form it needs to be in, and both sine and cosine are sinusoidal functions. So some of this is going to be the same no matter whether it's sine or cosine, and that is amplitude and midline. Those two things are kind of easiest things to come up with. So the midline looks like it's right here. Midline's not always 1, but it sure has been on every example we've looked at so far. Here, so you can use sine or cosine. What I like to do is think about what this graph would look like if it was sine, and think about what this graph would look like if it is cosine. right? Neither one of them are you going to be able to do with no flips or shifts, right? But if I had cosine, then my y-intercept would be at a maximum point, right? So I'd have a maximum point would be my y-intercept here if I had cosine. So notice that my y-intercept is actually at a minimum point. When you see that happening, it means you could just flip cosine and you would get the right answer. So I think cosine is easier to do because I think flipping is a lot easier than the phase shifts for these. So, so if you use cosine, you're going to have f of x or f of theta, whichever variable you want to use. We have an amplitude of 3, so we're going to put negative 3. The negative does the flipping, and the 3 is our amplitude of cosine of, we'll worry about this stuff here in a minute, and my midline is 1, so I put a plus 1 over here. Okay, what is the period of this graph? Pi over 2, because if I see how long it takes to repeat, that happens right here at pi over 2. So, again, you can set it up. 2 pi over b equals pi over 2. Or you could just go straight to 2 pi over 2 if you want to use that formula as well. Multiply by b. 2 pi equals pi over 2 times b. And then you're dividing by pi over 2, and dividing fractions is easy as pi. You flip the second, multiply. So I like to think of this as just multiplying by 2 over pi. Here, this is, we can make it a fraction. Here, the pi's are going to cancel. We will just get 4 for the b. So we got 4x right there. However, this is not the only way that you can do the problem, right? So you don't have to use a cosine for this. If you use a sine, several things are going to be exactly the same. You are still going to have a 3 for your amplitude. You are still going to have a 4 here for the b value that gives you the period, right? But you're going to need a phase shift here. So if we think of sine, let me use a different color. Sine usually has a y-intercept at the midline. All right, so this little green graph I have right here is what sine would look like if we did not shift it left or right. So it's the graph of what I've got here with no phase shift, except for I don't have my x in, but it would go right here if I put my x right here. This graph would look like that green graph right there, right? So I would need to shift this graph to equal the graph that we're looking for. So this green dotted graph would have to be shifted. Really, I could do the right or left, but I think it's easier to see the right because I like to try to match my maximums up there. So if I take this maximum right here and move it over this far, so I'm thinking how far is it from here to here? And that's half of pi over 4, right? So pi over 4 times 1/2 is pi over 8. So you have to shift to the right pi over 8 for these to match up. So you would have to do minus pi over 8. So this would be an option. You also could shift it to the left a lot further, but that's a little harder to see from the graph, so I probably wouldn't try that. These would be your 2 most common answers. Let's see. So you're saying do y equal, well, f of x equals 3 cosine of 4, then like extra parentheses, and then what have you got here? X, almost. You can almost do that. It's not, you don't want to do 3, because 3 is not really 3 like on our X coordinates here. So like if I'm thinking of that red graph right there, and I want to shift it all the way over here, it is 3 tick marks, but that 3 tick marks is pi over 4. So you can do that, but it would need to be a pi over 4 right here. And that would be fine also. That would give you the same graph. So some of these have multiple correct answers. On multiple choice section, there will only be one of them. So if they're asking you to write the equation and it's multiple choice, there's only one of these answers will show up. Which sometimes is kind of hard because your mind might be flipping the graph over, but really you're supposed to shift left or right on what they have. You're definitely going, free response question number 3 is going to be a sign modeling problem without a calculator. And any of these answers would be counted correct for those. So as long as it is correct. There's actually even more that would work because we could shift further left or right. It's just not, it would be harder. There wouldn't be a good reason to do it that way for that. Does that make sense on those? Okay, so we didn't really look at graphs much yesterday, so I wanted to look at that here. Did anybody run into anything, looked at it last night, that had questions about that you want to look at before I kind of turn you loose and let you do your work for today? Okay. Let's see. All right, let's just do 12 here together. And this is very much like what you're going to see on the actual like free response questions for this section. Okay, so we have the graph of H and its dashed midline for 2 full cycles is shown. 5 points are labeled on the graph. The scale is no scale is indicated and no axes are presented. The coordinates for the 5 points F, G, J, K, and P are given. The function H can be written in the form H of T equals A sine B parentheses T plus C plus D. Find all the values for A, B, C, and D. Okay, so for this, I would go through and label these points. So this is 0, 12. This is 5, 9. This is 10, 6. This is 15, 9. And this is 20, 12. So they have not drawn in X and Y axes on this. I think it is helpful for you to put in the X and Y axis on this. So I'm going to draw in the coordinates of this first point are 0, 12. So your X coordinate is 0, which means this point right here is on the Y axis, right? And like your Y coordinate right here is 12. And then the X coordinate right here is 6. And I am going to put a little squiggle mark right here, which means I'm leaving out part of the graph. And I'm going to put the x-axis down here along the bottom. So like, this is the point 0, 12. This right here is the point 5, 9. So your y-coordinate is 9. This right here is 5. This point right here is at your x-coordinate is 10. Your y-coordinate is 6. Right here we got 15 and 9. And right here we have 20 and 12. Now, they're telling you which type of graph you have to use. Are we using sine or cosine? Sine. Now, cosine would be easier here. It would be easier if they had told us to use cosine, but they didn't. They told us we had, oh, it's supposed to be my highlighter. They told us we had to use sine, right? So, what we need to do here is think about what sine would look like if it were graphed here, and think about how it needs to be shifted. Some things are pretty easy to find even without thinking about that, and that is amplitude and midline, right? So when I'm thinking about this graph right here, my A value, what is it going to be? It is going to be 3, because that is your amplitude. That's your distance from your midline up to your highest point, right? So A is going to be 3. What about D? That's the dotted line right here. That is 9. Your y coordinates on that line right there are 9. Okay, so those two I think are much easier to find. For the other parts, period, what is the period of this graph? What? Not 10, 20, right? Because you want to go like from here all the way back up to here, right? And then that's from 0 over to 20. So for that, the period of this graph is 20, but that's not our B value, right? 2 pi over B equals 20. Well, that just means we're going to multiply by B. 2 pi equals 20B divided by 20. And that is going to reduce to pi over 10 for the B. So my B value is pi over 10. And the last part, we got to think about how we have to shift this. So for this case, sine typically has a y-intercept at the midline. And then it goes to a maximum point, back to the midline, minimum point, back to the midline. All right, so this green graph that I've got here, that would be the sine graph with all of the A, B, and D that I have that has not been shifted left or right. So we need to take my dotted graph and we need to move it to the place that we see, the solid graph, right? You have two options here that are pretty much equally easy. I would probably go to the left here. How far is that moving? That is 5 units, right? So I would probably say C equals positive 5. You want to use the opposite direction, right? If you want to move left, use a positive 5. Here, what's another option? What else could you have for C? Not minus 5. Minus 15. Because minus 5 would only move this over here. You need to move this dotted line all the way over to the next maximum. Right here. So like if you wanted to move the opposite direction, if you wanted to take that maximum point right there and move it over this far so that it would line up, that would be 15 for that. So you'd have to have minus 15. Okay. If you are thinking minus 5, you might be thinking about this like midline point right here. It does kind of look like, oh, I could just move it over 5, right? But if you did, then it wouldn't match up with the rest of the graph. From here, like that point would match up, but then it would go up instead of down at that point. So I would highly suggest when you're thinking about shifting here, use the maximum or minimum to shift, not the midline, because those get repeated for those. So I would do 5 here, but you could do negative 15 and you would still get the right answer. Yes. If you had a -3, it would be flipped. So a -5 would be fine if you also had the -3 with it. Yeah, so you could do that also. There.
Could we also do number 13?
Sure. Okay. This one has some pi's, makes it harder. Also doesn't start at 0, makes it harder, right? So I would always start by labeling my points. So this is pi over 2, 6. This is 3 pi over 2, no, over 4. -1. J is pi, -8. K is 5 pi over 4, -1. And P is 3 pi over 2, 6. I think that these are tough whenever you have those radians. First of all, it's kind of hard to even see what you're counting by here, right? It was much easier up here where my x-coordinates were 0, 5, 10, 15, 20. I could very clearly see I was just going up by 5s on that x-axis. But here, I've got pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2. What is my x, like what are my x-axis? What is that x-axis increasing by? Hard to tell, right? Here is a suggestion. It is sometimes helpful to give everything common denominators, right? So if I've got pi over 2, 3 pi over 4, just pi, 5 pi over 4, and 3 pi over 2, if you go with the biggest denominator, 4, right? Let's get them all to match 4. So I could say, if I multiply this by 2 on top and bottom, this is 2 pi over 4. That one's 3 pi over 4. This is over 1, so I'd have to multiply by 4 on the top. So I've got 4 pi over 4, 5 pi over 4, and then I'd have to multiply by 2 here, 6 pi over 4. So if I think of this way, I've got 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. What's my x values increasing by? Pi over 4, right? We're going up by pi over 4 each time. So, on the x-axis, I'm going to actually have to go backwards some. I'm going to have to sort of extend this out. Here, because this right here, the x-axis actually runs, let's make this, I guess, black. Right here, the x-axis actually runs through about right here. Right, maybe not exactly there. But notice that my y-coordinate is -1 right here. And so this right here is, I'm just going to call it 2 pi over 4. And this is 3 pi over 4. And right here is 4 pi over 4. And this is 5 pi over 4. And this is 6 pi over 4. So to get back to the y-axis, I've got to have 1 pi over 4. And then over here, I'll get back to 0. And that's where my y-axis goes. And I need to extend this graph on out a little bit further. Okay, for the y-axis to label it, my y-coordinate right here at that top point is +6. At the midline, my y coordinates are -1. This is a +6. Looks like a negative there. And then my my lowest point is -8. Okay, so now that we've got our graph, right, let's fill in what we know, okay? I like to start with A and D. I think they're much easier to do, right? What is the A value going to be here? 7, right? Because from -1 up to 6, that's a distance of 7, right? Or from -1 down to -8, distance of 7, okay? We need to find B, and we need to find C, but they're a little harder, so I'm going to look for D here. And what would I get for D? D's the midline, that's -1. Okay, so, and when these are on the actual, like, FRQs, this part is going to be worth 2 points, and you get a point for getting 2 of them right. So these 2 are much easier to get right than the other 2. Here, then we need to think about the period and the midline for this. If you have extended your graph on out, I think it is so much easier to start at 0 right here to think of the period of the graph. So the period of the graph, you would go from 0 over to pi. So the period of this graph is pi, right? So that means 2 pi over b, the way that we find period, has to equal pi. And what does b need to be in this case? It'll just be 2 for that. You have to get 2 to get the first point, so it'll be worth 2 points here. So if you get 2 of them right, you'll get 1 point out of the 2. You have to have all 4 to get the full credit on these points. And then C, we need to think about shifting. So if we are using sine usually has a y-intercept at the midline, and then it will go to a maximum, back to the midline, minimum, back to the midline. So I like to actually draw in a dotted graph right here. And remember, you're always trying to move the dotted graph to the actual solid line graph. A lot of times kids use the opposite sign that they should because they're moving the solid line to the dotted line, which will get you backwards. So right here, I like to look at maximums because they're easy to track. You could also look at the minimums here. I need to take this maximum right here, and I need to move it over to the right this distance. How far is that distance? Pi over 4, because it's one tick mark. You're going to pi over 2, but you started at pi over 4, right? So 1 tick mark is pi over 4. So we want negative pi over 4. You're using the opposite sign. Since we're moving this graph to the right, we want to use a negative for that pi over 4. Okay, questions? They're a little tricky, but you'll get pretty good at them eventually. We're going to do several because the third FRQ is going to have a graph that looks like this on it every year. So we're just going to spend the rest of the time working. I'll be around to help. I want you guys to finish this worksheet. The keys should be posted so you can check whenever you get it done. So when you finish, if you'll check your work and see how you're doing. Then I also have assigned a Delta Math assignment here, and it has 3 sections. The first is just going to ask you things about like what's the period of this graph, or what is the amplitude of this graph. So those should be very quick problems. The next part will ask you to write a trig equation. These do not require you to use sine or cosine, so you could use either one for these. And then the last is some matching with trig graphs. Here, this one actually might be easier than the middle one, if you want to try it first here for that. So like when I'm looking at this, I can see they all have the same amplitude. Which one of these, is this going to be sine? They're all flipped, right? They all have negatives. Is this sine flipped or cosine flipped? This is sine flipped. So it's one of these two. And then what's the period for this graph? Not 16, 32. Because, and I know they're tiny up there, but because you got to do both the negative part and the positive part. Or you may have been answering the b value. The b value is going to be pi over 16, because you got to do 2 pi over that 32. So you would get that one right there. So you're going to work on this after you finish the worksheet. These are due on Monday.